All right, so today we are going to talk about evaluating and simplifying with exponents from Chapter 2, Section 7. So if you want to get out your notes packet, if you haven't already, with your writing implements, and let's get started. Make sure you're on this right page. So we're going to start by talking about our exponents and our rules for them. So exponents, as hopefully you do remember, are these smaller numbers on the top here, which indicate that you're multiplying something by itself. So for example, if I've got x to the a, that's x times itself a number of times. So if I have these terms here, where you'll notice that they are like terms, they have the same variable. We call this the base of the exponent. It might be a variable, it might also be a number, like you can see here in 2. The base of the exponents is 6. If you have the same base, you are allowed to simplify by adding the exponents together. So this would stay the same. You'll notice we still have a base x, simplifies to a plus b. So for example, if I have simplify x to the 4th times x to the 6th times x, we can start by simplifying just these first two terms. They have the same base, x, and then we can add their exponents. And then we just keep this term sticking around for a second. And then we have x to the 10 times x. Now you'll notice that these are like terms, but what looks like one doesn't have an exponent. In fact, it does. We just often don't write it the same way that we don't say x plus 3x. That's 1x plus 3x. Here we have x to the 10th times x, so this is x to the 1st. So if you want to write that in, that's great. And then you end up with x to the 10 plus 1. And we get our final simplified answer as x to the 11th for this long multiplication problem. Now, as I said, it works the exact same way if you have a number as the base instead of a variable. One thing that's important to remember, though, is that you'll notice that the base is staying the same. Here we have x, x, and x for these problems. Same thing's going to happen here. Our base is 6. So in our answer, we're going to have the base 6. Some of you are going to make this mistake, so make sure that you are keeping that base the same. And then you're just adding the exponents. And this simplifies to 6 to the 10th. If you want to grab a calculator and find out what that is, I will let you, but you don't need to, and it's going to be a very, very large number because this is 6 times 6 times 6 times 6 all the way out 10 times. And that's going to be a very large number. Now, that's one of our rules for exponents. We also have two more. We have where x has an exponent of 0, and then we also have division. So one thing to remind us of is, we'll put this in just as a good memory holder, anything to the 0 power is 1. And this is something that not all of you are going to believe, is that anything to a 0 power is equal to 1. And I am going to prove to you that that is true in this next example. But you'll also notice that this example has a division symbol in it. So we'll also remind ourselves again that if we have x to the a divided by x to the b, that this is where we get to subtract our exponents. So when we multiply, we add. Division, we subtract. If you can't remember that, the nice thing here is that that kind of looks like a subtraction sign right there. So if that helps you remember it, go for that. So in this case, we're going to see we have y to the 3rd times y squared over y to the 5th. So they have the same base, so we can use our rules. They all have the base y. Now the first thing I'm going to do is I'm going to simplify the multiplication here. And I'm going to say, well, that's in the numerator, y to the 3 plus 2, y to the 5th. And that gives me y to the 5th divided by y to the 5th. Now from here we have two options, and this is how I'm going to prove that this is true. If we use our subtraction rule here, we would then get y to the 5th minus 5, which is y to the 0, because we are subtracting the divided exponents. You also could say, well, this is a fraction where the thing on top of the fraction is the same as the thing on the bottom of the fraction. And if we have the same thing on the top of a fraction and the bottom, that's equal to 1. Because they all cancel out. So you already know that this is true from your rules of division. 7 over 7 is 1. 36 over 36 is 1. And so on. Well, but we know that 1 is also then y to the 0, since both of these are equal to this fraction. And that's how we get that this is true. So either way, we get our answer of 1. Let's take a look at two more quick examples. Here we have simplify a to the 4th over b squared. Now here, some of you might think of as a trick question. It's not a trick question, it's just a very easy question. This is already completely simplified because they are not like terms. They have different variables. So it's just a very straightforward problem. Now in number 5, we've got 4 to the 6th over 4 to the 2nd. These are like terms. Again, it's absolutely fine as long as they have the same base. The rule will still apply. You'll notice again the x stays as an x. So 4 to the 6th over 4 to the 6th will stay as a base 4. And then 6 minus 2 to use our subtraction rule here. And then we end up with 4 to the 4th as the simplified answer. Now this one is not going to be quite as bad to expand all the way out by hand. So you can leave it as 4 to the 4th. If they ask you to evaluate farther, this is 4 times 4 times 4. So 4 times itself 4 times, that's what the exponent says, which is 256. Just this one's much more doable. If you have any questions, please leave them in the comments or make an appointment in the calendar. Hopefully you have a great week, and I'll talk to you all later.